How's it going?
Good. How are you?
Doing good. Just talking to all 35 folks watching me right now. Watching me go through a heck of a time as I rewrite a system for the second time. I just needed to get it done, though.
You're doing a second rewrite? Oh,
Eh.
I'm sorry.
It's okay. Logan's just going to be pissed when he finds that all the code he's written is going to be gone. Like, all of it. Alright,
You hungry?
Kinda hungry.
What do you want?
That's a good question. Ty sounded really good last night.
Thai.
What? You make
Okay.
faces.
No, I'm not making a face. I'm considering.
Okay. Right, guys? Thai food? Thai food's good, right? One sec. I'm in the middle of something.
Just one more. Thank you.
There you go.
Alright, I'm gonna look at Thai food.
Okay.
Guys,
And see, now I forgot what I was working on.
you were rewriting stuff.
Yes, but
Sorry.
it's okay.
I'm not sorry.
No, you're not.
No, I'm not.
Vertices, edges, center. I am setting these to null. I think I removed the to-do. Initialize cells in array to null pointer. Yeah, they're getting initialized correctly. When they get initialized here, I'm passing in the null pointer through here, so they're ending up in here in the end. Yeah, this is just a standard Visual Studio compiler, La La Land. I find it really bizarre that it's, like, unhappy, because it's using standard C++11 features, right? Like, null pointer is a C++11 feature. So this should work. No idea. Okay. And if I run this, no complaints. Okay, well, I'm not seeing any complaints anymore from the system, so I'm honestly just going to go so far as to say this works, and I was just running into a bug of some kind, I guess? I don't know. It's really weird that this was happening. Really weird. Okay, so this all works. So now the next step is to get it to generate mesh data from this cell data. Because remember, we've turned off this. This is actually code that I think can be deleted. Yeah, it can. That can go away. Let's see here. And then this code that says create cell is also kind of unnecessary at this point, oddly enough. Okay, so this create cell function, we've already copy and pasted most everything in here and kind of pulled it out. There's a workaround. Uh-oh. What? So I thought I tried that, and it was unhappy doing that as well. Let's just try it once more. Because I'd be happy if I could get this over to the initializer section and not actual code that gets run separately. Vertices, V1, V2.
Can I say you?
Yes, please. Expected that. Yeah, it looks like it's going to be unhappy with that too. Cannot specify explicit initializer for arrays. Ugh. Yeah, I don't know, guys. This is... I kind of understand why, but it's a pain in the ass too. The reason I understand why is because you can say, my array is 2 elements long, and then attempt an explicit initialization that is a different element size. It's still dumb. Also, it looks like they're... It looks like the example that fixes it uses the standard array class, and I don't have access to that because I don't have STL or anything standard. No, I don't have any of the standard libraries. So that's fine. We'll just leave as is and fix this up as we go. So the only thing left that needs to exist inside inside the cell is this. This last bit of code needs to go inside a cell. Noise value, scaled octave. Da-dump, da-dump, da-dump. Let's see here. We need QRST. Pound include simplex noise. Cool. Let's see. Elevation equals. We need to pull that sort vertices function over. That shouldn't be the end of the world, though. And the nice thing is, we don't need this sucker anymore when we tell ourselves to sort vertices. Although, yeah, and we don't need this either. Okay. Biome type. Does biome type not exist in here yet? Oh, I see. I changed the name. Derp. And you'll notice how easy some of the rest of this code has gotten as I fill it in. For example, before I had all these other things that were calling functions on other functions, and they're doing some crazy stuff that really wasn't necessary. And without this code, yeah, sure, load changes. Without some of this code in place, it's simplifying heavily. A lot of things are kind of just falling into place where they should be. Let's see, we need the cell class specifically. We need this diff so we can find sort vert. I'm just going to do that and we'll find it pretty easily. Sort vertices. Now this code, I believe in it. I really want to, at least, because I'd be frightened if it didn't. Sort void sort vertices. This will be the one piece of code that survives my my reckoning, hopefully. Vertices, there we go. I would laugh if this didn't make it either, though. Vertices, or you just say vertices I. Although that still gives me just a pointer. So we need to dereference that. Also, for some reason this uses J. Why does it start at J? Oh, code. You so goofy. What built-in sort? That's my question. There is no built-in sort. La La Land, you're assuming I have access to a lot of standard functions, which I don't. Because the vertices, because the engine because the author of this engine wrote his own memory manager, it becomes problematic to use STL and even standard namespace stuff. It becomes difficult to use. So he's got a lot of his own stuff in here. And this is the kind of sorting that does work over the 2 pi to 0 boundary. It actually works specifically with that, as far as I know. But yeah, it's just kind of painful that I have to do some of this stuff, but also a necessary evil in some ways. Let's see, vertices. Da-dump, da-dump, da-dump. You should be able to pull a... Yes, and then... Oh, remove element. That doesn't exist anymore. Let's see here. Vertices J. Vertices K plus 1 equals temp. Vertices J equals... Wait a minute. There we go. I've done this before, I swear. I program on a regular basis. I just, and then, oh, the insert element should actually be at K. And then this is temp, and this is actually K. There we go. Oxios, I don't know if I'm going to get to that point tonight. I really hope I do, but I don't know if I honestly will end up at the point where I can do that. So, we'll see. Fingers crossed. But, also, what is else if K equals 0? What is going on here? If the angle current, or if the angle, or if K is equal to 0. Oh god. K is J minus 1, and then if K equals... I'm gonna have to... I don't think this exists anymore. So I should just be able to say, or K equals 0. And this should still operate. He just made a little... Oh my gosh. Yeah, we'll just kind of... In fact, I'm going to go so far as to just comment this little hunk out, just in case I need it later. If something is really unhappy in here, we can get around to fixing it. Terrain generation, let's get this get terrain height function and min height. Let's see, where is that wanted? Inside the cell, so the cell can find its own height. I'm trying to see if I can pull this terrain generation, like, namespace out entirely. If I can write enough helpers and do this correctly, that's honestly all I should need. And at that point, once the helpers are doing all the hard work, I don't need all this other stuff. So let's see. Let's see if we can do this without that other class. Specifically, scaled octave, get terrain height. Okay, good. I'm going to leave that breakpoint there just in case. Okay, so these exist and these are fine. We'll leave those for now. We'll do cleanup later and delete stuff. Okay, so build terrain calls create cell system. Create cell system is honestly little more than this. So let's see if I can do this. Cell system. Haha, whoops. The world generator is complaining. For what reason? Oh, because I changed the name of things, and it's, of course, unhappy about some of the name changes I made. Let's not spawn the water geometry in the trees in quite yet. There we go. Alright, so we're at the cusp of the point where if this runs just fine, okay, I'm not seeing any errors, although then again I wouldn't see much that's going wrong right now anyway. So what we're now going to do is find a good way for all of the cell groups to generate their own geometry data, and then from there we'll pull out the information that we need. So let's see here. A cell group needs to be able to generate a mesh. So first off, cell group needs a public generate mesh function. That, let's see, does it need anything specific? I don't think it does. Mesh cell group. Here you go, cell group. Cell group. And thank you guys for bearing with me so much. I mean, this is kind of a big task, and I just kind of dove onto it a little haphazardly, so to speak. I just kind of saw the need for the change and started in. So, you know, for those of you who are putting up with all of this crazy work that I'm doing right now, thank you very much. It is very appreciated that you guys are here and helping me, and at least, you know, we're both getting something out of this. You guys are teaching me all kinds of stuff, and I'm hopefully helping you guys learn some stuff as well. Alright, so generate mesh. We need to go through and essentially take all this code that's sitting out in the world generation and merge it with some of the code that used to be in this cell class and put the two together so that we have one geometry object that's getting generated for all of this stuff. Specifically right here. Yeah. Even this maybe. No, just this. Just that. Nope. Wrong class. Here is where I want this. So material objects, we're going to pull in our vertex coloring object. And then we're going to say, we don't actually need access to this. We're going to say for int I equals, please tell me I have something easy to use in here. It should be cell array, man, is there an easy way to tell? I guess, I mean, we can do a standard size of, but that's... I was kind of hoping there'd be an easier way to know, other than just doing range. Oh, no, range isn't bad. Int cell count equals range.min.x. I guess I should say .max.x minus range.min.x. I just want to make sure that this is also how I'm size times resolution, where so it should be that times the resolution, unfortunately. Let's put another counter in here just for simplicity's sake. I kind of hate to do this because it's going to be standard across every single one, but it's also going to be a nice little helper to have around all the time. So that's why I don't mind creating it. Cell count equals, and maybe I can find a better way to do that later. I want to finish this though at a decent hour. Read sooner rather than later. So let's see here. Cells or the cell array specifically, I. Dot, not sort vertices. Actually, I need to make sure that's getting called from the cell. Yes, that is. Okay. Generate mesh. Something like this is what I want the final thing to look like. Okay. This can also go outside. So the idea is we create a bunch of geometry surfaces, and then we're going to meld them together into one geometry object. And hopefully that will help us create... We might even be able to merge these all into one surface if we got really nitpicky about the whole thing. I don't know if we're going to see the same savings from having a bunch of geometry surfaces, or if we need to merge them together. Let's do one thing at a time. We already have the code for this, so let's just kind of go one at a time. Cell group has a center, so we're going to do that. And then, does the cell group... No, the cell group, of course, is not going to have an elevation. This will just live at 0 for now. Yeah. I say that questioningly because I'm not entirely certain. There we go. And then the cell's terrain node. Okay, we don't need to worry about the cell's terrain node anymore, at least. So we just have to add this into our cell group generate mesh function. And then where we call generate mesh, we call build terrain. And then the graph needs to, as part of the generation, call this generate mesh function. So where's our cell system? When you create a cell group, that new group should probably generate a mesh. Let's see, a terrain root node is going to get passed into here, which is going to expand our create cell group function ever so slightly. And then this, what? Oh no, this is where I'm looking, or I should be looking. Let's see here. Oh, here's our supernode that should be getting created before all this, it looks like, huh? That's fine. Terrain supernode goes in here. And then generate mesh is not a member of cell. That's fine. We will fix that. What did the old one look like? Yes, load changes. Specifically, I actually don't want to look at that one. I want to look at that H file. Tortoise diff generate mesh. Where are you and what do you look like? So that's the new one. Really? There was a generate mesh function before inside of cell. What happened to it? Here it is. This is really what I care about, this return value. Generate mesh. And I don't think I actually need anything in here. What? Oh, okay. The linker is just like, nope, I just failed. Any reason why I don't use Visual Studio internal version management? Does that exist in the Express mode? And if it does, I don't know. I guess I'm just not used to using it. I don't even know where that would exist, honestly. I use Visual Studio mostly as just the compiler and linker, and I don't really think about much else that it can do for me. Keep the style consistent. Sort vertices. No, I want the other sort vertices, the one that's written and done. Okay, cell. Where's the other generate mesh function again? Generate mesh. There we go. I'm just going to cut and paste in this case, so I don't have to futz with anything here. Cell system, cell group, cell generate mesh. Bam! There we go. We still want min height and max height getting passed through, which is fine. What I'm going to do is we'll just, at the top of this, we'll get terrain minimum height, float max height equals get terrain max height, and these are pre-written at the top as helper functions. You can ping get. Oh! That's cool. I don't know. I'm not using Git. I'm using SVN. I don't know if it has the same functionality for SVN. Just not something I guess I've really thought of doing. I need to look at that once more. Whoops. Diff. Specifically, I need to find, what was it? Find valid. Should be enough. Find valid. Oh, actually, I wonder if it still exists here. Find valid. Here it is. Except that obviously this thing is very different now. That's the one thing to keep in mind. Now that I've done some of this work, some of it has changed so much that I actually am not thinking much about it. So it takes this and it takes that, and we're not going to worry about that. So we clear out the array of cell edges, and this isn't an index array, this is just an edge array. I don't know why I named it so poorly, but we're not going to worry about that. I is less than 4, plus I, edge, we're just going to look at the cell. Oh, I don't have a get edge function, do I? I guess this is the time to write one. Get edge. Int index. Return edges index. Get edge I. And then we say if. Oh, this needs to be made const too, just so we don't muck with anything. And then we say this edge. We can grab the neighbor. So this is another function. I like to write these little helper functions inside this, inside these classes. Specifically the cell pointer get neighbor in the IGHBR. There we go. Which takes in a cell pointer C and is const. Let's see here. Contains vertices. There we go. And because these things are just kind of over what I tend to write for getters and setters, I don't like them to exist in the H file, so I don't bother with that much. That's kind of a personal preference thing, but I like to also not fill my header file up with too much garbage. I want the header file to essentially be a summary. And when you need to know what the actual details of something are, then you can look at the definition instead of the declaration. So, cells 0 equals C. Then we return cells 1, otherwise cells 0. Now this is not a foolproof method. This is simple, but this can obviously cause us some trouble. Do I want to guard against idiocy? Nah. Nah. This will probably bite me in the ass later, but we're not going to worry about that right now. We're going to say we grab the edge, we grab the neighbor out of the edge. We're going to say edge, get neighbor, specifically from C. And I noticed that because this should be const as well, get neighbor, crap, get NEIGHBR, nope, there, you. Oh, come on. There we go. Get neighbor, if the neighbor's not a null pointer, and cell needs a get elevation. Return elevation. Ta-da! And I don't like get cell elevation if only because it's obvious. You're already using cells, so why do you care? Nope. Vertices. So the top vert count is always going to be 4. Because it just is, right? Like, they're squares. There's no reason to do anything crazy. Now the skirt edges, that can change. So I'm not too crazy about that, but at bare minimum, let's see here, we can do vertex indices I. That will give us a pointer. We need to get the reference of that minus center. Also, it's not vertex indices, it's now just vertices. Oh, almost there. Almost there, ladies and gents. Edge, get neighbor, we pass ourselves in. The mesh vertices, oh, okay, now we're talking about the mesh vertices specifically for every place I use origin. I'm going to have to swap to center. Not the end of the world, just bleh. The other cell, the owning graph, get vertex position on, okay, so edge needs a get vertex. So for point, 2D pointer, get edge into IDX. Once again, just return vertices IDX, and that should not be get edge, that should be get vertex. Brain, you so silly sometimes. Okay, get vertex, get vertex 0. And we just, our usual stuff, except that you and you are the same. And then you become get vertex 0, and you become get vertex 1. See, notice just all of this stuff is just compacting down so beautifully, and I absolutely love it. Other cell, center, minus my own center. Granted, the last rewrite is also helping a lot. A lot of the work I did the first time through is really, really helping. Let's get some, let's see, music. Are you going to play an ad? Please don't play an ad. There we go. Alright. Yeah, the good feeling of refactoring your code. It's so nice when it works. We'll see. Okay, obviously we have a little bit of trouble here. Yeah, we don't care about you anymore. Nice epic music, right? For my refactoring. Okay, we're calling generate mesh from inside the group where we are. So the only worry I have is that we're creating the cell groups and then we're not attaching them to each other, but I guess we can fight with that later. So the new cell group should exist, right? And then we call into generate mesh, which we have the material set up, we have the list, the cell geometry list, and then we append in this cell's details. And for some reason the skirt edge list is coming back empty. Why? Where are you breaking? So the edge, okay, the edge is coming back as garbage. So this seems to think, if you look at all these vertices and edges, oh my god, what have I done wrong? So I'm filling in the cell details incorrectly. In fact, actually, was that? Dang it. Okay, more breakpoints. Let's see what's happening in here. So you notice these vertices and edges are all garbage, right? That's not good in the slightest. And if we look at the vertex list, it's empty. Granted, I guess, is this our first pass through? Yeah, this is the first thing. So, let's see. Can I look at this pointer? What can I see? You should be empty. Oh, but these are, okay. This is fine. These are all garbage, and I should be filling them in right now. So, you don't exist, I add you to the list. You don't exist, I add you to the list. So we should have now 4 valid vertex pointers, which here they are, and they are perfectly good data. And then the edges don't exist either. So we have 4 valid edges as well now. So that all looks good. And we set our own biome, and then we set our own elevation. We sort the vertices. Did that break anything? Nope. These still look good. And they look like they're in the right order. So that's good. Now the question becomes... Okay, C is no longer a found identifier. Cell array. So that was cell array 0. So this 0th index should and does have a valid set of information. And that's the only one in here. So this cell group looks good. We take that new group with its single cell, and we insert this group into our cell groups. And look at this. This looks fine. Everything here looks gorgeous. The vertex array has its 4 elements. The edge array has its 4 elements. And then we tell it to generate a mesh from this one piece, of which it has 1. Oh, you think you have 16 cells inside of you. Why do you think you have 16 cells? Oh, because the size here. Derp. Yeah, nope. La La Land beat me to it. Just as I found it, I look over at chat and I see his lines appearing. Oh, my brain. Why do I do this to myself? So cell count, size times resolution, and size times resolution. That should honestly be what it should be. Let's just make our own int that's called side length. And actually, we can do this earlier. And now we have for y and x. Okay. Side length, good. Good. All this data should be good now. We'll, of course, see if we get any further. And we still don't. Why? Let's look around. Okay, C looks to be valid. The edge looks to be deleted. What? What? Why is this edge deleted? Or at least... Yeah, it looks like something here was deleted. I'm not 100%. But, does this happen the first time I call it? Yes, it does. Okay. So... we've got this edge array. And we've got the cell. Okay, so we step in. And if we look at the this pointer, we can see our vertices look like garbage. Really? Those are not good vertex positions. Not a number? Yeah, no. Why not a number? Why not a number indeed? Okay, cell position looks fine. We grab the pointer. We then fill the pointer with all the goodies. And I'm just going to jump to the end. And if we look at our vertices, those look valid. Okay, so, and if we step over that, do we break them all? No. Okay, so I think this function is clean. I think that constructor is just fine. In the cell array, if we look at the edges, everything here looks good. Right? You've got a pair of healthy looking pointers to vertices, yes. So, y size plus x. So we get a new pointer. We fill in your details. And we're going to add in hopefully only 2 vertices, although it looks like it's adding all 4 in. And then we find the edge. So already I'm seeing a possible issue that I'm not entirely sure about. In that it's not sharing any vertices. It's almost acting like this vert list is empty. I hate to do it, but let's double check this real quick. You are fine. Okay, so our 4 vertices, we are going between, I'm just going to scribble this down on a little piece of paper in front of me, going between -1 and -0.75 as our min. And our min plus size, what is our size? 0.25, so cell vertices 2 is 0.75, specifically -0.75 and -1. Did I do that right? I don't think I did that right. Yeah, no, I didn't. -1, -1 to -0.75. -0.75. Okay, there we go. 1 down. Properties, go away. I didn't actually ask for you. Not specifically. Okay, F10, F9. So the second one goes between 0 and -1. What? And it goes between that and... Come on. And 0.25 minus 0.75. Now... plus x times size and min plus y times size y size 1 size is wrong. I think size is wrong. Yeah, we're never doing the oh crap. Okay. We're never doing the swap between integer resolution and size, like cell size. So float cell size equals that. So this should honestly not be size, it should be by cell size. That's what we should be moving this around with. And then C equals that. Yes, that looks fine. Okay. See, we're just ironing out all the little kinks we accidentally left behind for ourselves. So, first one is as expected. Second one should be... Yep. Let's see. Min is also -1, -1. What? Double check this. Da-dum, bump, bump, bump. Okay, first time through, our minimum is -1, -1. Second time through, our minimum is -0.75 and 1. Good, 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 good. Okay. And this should start finding common vertices. There it goes. 1 common vertice. 2 common vertices. Good, 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 good. And I'm being told... Let's see, line 273. Should be side length? No. Line 273 should not be side length. Although, I think this is what you're talking about here. This should be cell size instead of, what was it before? Oh no, it looks like it was cell size. That looks fine. 273 is fine because we're pulling the pointer out using let's see here, size y plus size times x. Should that be size times resolution? Or side, oh yeah, okay, never mind, you're correct. Side length, derp. Good eye there, La La Land. I'm very happy to have you along. Thank you very much. If you haven't subscribed, or if you haven't followed, why don't you follow? Just so I can always use you as a fantastic reference. It's like pair programming, but with, you know, 38 of you. Let's see. 30, I don't know. That would be a triaconta octagon. So is the polygon name with 38 sides. So it'd be, yeah, I don't know. I'm not gonna futz with it. Whatever. Okay, still breaks, but we're getting closer. So it's still the edge vertices that look like they're garbage. So we should probably keep an eye and see what the heck is going on with those edges. So whenever I insert a new edge in, I need to double check and make sure everything is hunky-dory. Dum-dum-dum. Sort vertices, edge. Specifically, you. Vertices, and I'm using vertices and not cell vertices. If we look at the edge list, you now contain an edge of good data. Okay, what is... I is 0. So this is the first cell, and we're telling it to generate a mesh. And the first cell, upon attempting to generate a mesh, says that its neighbor that it is getting from the edge is garbage. So we have a good... Ooh, actually, even the local cell looks like garbage. Or it looks like it's full of bad edges. Dump. Edge set cell. So will this edge ever expire? It shouldn't. It really honestly shouldn't. I mean, we'd see it immediately if the edges went bad here. But they look fine. Okay. So you create what should be 16. Oh god, I don't want to go through all that. That's overkill. So you create all of your things in a new call. Where am I allocating the cells? Let's see here. So I call new on the cell group, and then the cell group allocates all the new cells, or all the cell pointers, I should say. And these should be pointers which should... No. I think I need to be calling new on this system. I think I need to be doing... No, that wouldn't work. Let's see, I get a pointer. Yes, I know. So I allocate the cell, like, I allocate the space for the cell pointers, I should say. Right, because this is, that. Need to do equals new cell. Oh, crap. Oh, La La Land, you must be a compiler. You Really must be, because yeah, no, cell pointer. Cell array is a new cell pointer array. Why are you complaining? Because that should be a cell double pointer. Ugh. You are my savior. Thank you so incredibly much.